Welcome to the introduction of laslook. Laslook is a new tool within LAStools, the ultimate tool to handle point cloud data in the Open LAS or LAS formats. We expect you to know what point clouds are and what the general possibilities of LAStools are as well. After starting the program, you will see the main screen. This is more of a working environment than a single window. In the top left, you will see all of the LAStools. Below, we have provided a file browser to give you an easy overview of the files you are working with. Below the file browser, there is a file preview for the selected file. In the main working area, you also have a tab set of different modules. By default, you have access to the 3D viewer, documentation, and the argument finder. Below, we have our execution area or console window. We will go through these different views step by step. In the list of tools, you will see every tool with its single line description. Selecting a tool will show the arguments or the selected tool in the argument column. Selecting an argument will show the parameters of this argument and might show a sample of this argument as well. In both windows, you have a filter field to incrementally filter the items in this list. This feature gives you a very quick overview concerning the available tools and their arguments. If you want to have a closer look at a tool, you can simply switch to the tool documentation view. The tool documentation synchronizes with the selected tool. The information you receive you may already know by the README files. There are some additional advantages. First, we are given a formatted view. The markdown of the readmes is used to colorize the content. Then we can use the structure of the headers to generate a content list. You can click the content entry to jump to the position in the file. Either directly within the editor window or within the filter field, you can enter a search term. This term is used to search within the current document as well as in all documentation. The found positions in the file are highlighted. Positions in other files are listed in the global result list. Use F3 or F4 to iterate the matches. A click on the global result column opens the first position in the selected file. But what do you do if you don't know the argument you are looking for, or which tool is suitable for a certain task? Well, we built a global argument database for this very issue. This database contains all arguments of all tools with their descriptions and possible parameters. Global search box allows a scan of all arguments and descriptions. So, if you enter SHP, you will see all tools supporting SHP as an argument. You'll also see to which group these arguments belong. If you're interested in tools supporting SHP as output format, you then select this cell and you will then see the tools marked by a green marker in the tool list. By selecting groups, you can filter for results of the selected groups independently. This argument database, together with the tool documentation, gives you swift reference information about the capabilities of the tools. But now, onto the usage of the tools. The classic LAStools are command line tools. Therefore, we've integrated a command window. You most likely know already how to run LAStools commands. In principle, it's still exactly the same, but we want to give you a bit more confidence in building the command files. So if you want to use a command, you just double-click on it via the tool list. Then you double-click the data file you want to proceed with out of the file list. Then you filter and double-click the arguments you want to use. And here you can change the default parameters of an argument. We add another command, LASTile, and connect it to the file. Finally, you press F5 to run the whole batch or Control Return to just run the selected command. the process will be started. Some new execution threads will be opened, and to every task we get its own output frame. During execution, you will see the output of the tool. If an error occurs, the output and the editor line become red. If the command execution was successful, the output will become green. In our sample, we got an error message because las does not create a non-existent output path. This isn't a problem, as we can just create this path using the console. So, laslook is a workbench for LAStools, and good for testing commands as well as for your daily work. If you have automated workflows, it may be useful to test commands here. To run them, you will certainly still use your classic command files, which is why you have an option to save the content of your console to a command file. You can either give a name by dialog, or you just enter a comment at the first line and that name will be used. Normally, the mechanism behind the console parser tries to parallel your tasks. If you don't want this, you just click on sequential. Press Shift Escape or click Abort All to reset the execution stack. Working with the console means always working with files we have in our project. At the left side, you will see all files within our project directory. This is an integrated file browser. You can select files by click, mouse wheel, or cursor movement. As soon as you have selected a file, the file information window shows an initial preview of the file. LAS files are shown in a manner you are familiar with from LASinfo. Text files are shown as text, while pictures as pictures. In any case, you have the option to display the hex content of a file. The preview supports LAS, text files, and common picture formats. The browser is synchronized with the console. As soon as a new output is generated, the browser will show this file. In the toolbar, it is possible to change the directory in several ways. Show the directory history, filter files, or sort them by name, size, or date of change. You can hide files you do not want to have in the list and make them visible again. Now, I want to show you the 3D viewer. If you select a file in the file browser, it will also appear in the 3D viewer. At first viewing, we only read some 1,000 points of a file. This simple trick makes the first view extremely fast. And it is often enough to view just a smaller sample of your data to rate the quality of a point cloud or a result. If you want to see all points, you just press Show All Data, and the full file will be loaded. For each file, you can decide how the points will be colorized. I'll show the sample on our tiles we just created. If a colorization by value is selected, it is also possible to select the color scheme. The color schemes are configurable by the user. Additionally, you can change the point size of the points and the background of the view. View direction is modified best by mouse. Just click and move to change the direction. Z orientation will be fixed upwards by default. Shift-click move will move the point cloud within the XY plane. Control-click will move the cloud within the Z plane. Right-click move will move the center of your view to another position. This defines the zoom center of your view. Zoom is done best by mouse wheel. All view properties can be viewed and changed at the 3D control panel. More properties, like Z-zoom, can be achieved via the control panel. In addition, you can change all view settings easily by keyboard. The most important thing to note here is that the numpad should be set with numlock off. Cursor keys will move, plus, minus will zoom, Shift will decrease step size, Control cursor will move the center, slash will toggle between top, left, right views, and center will reset the view. A standalone feature is the capability of showing more than one file at the same time. As soon as the multi-view option is active, the files will not be synchronized automatically. Instead, you will see a view icon next to each file. If we want to show this file in view, we click this icon or select the function in the context menu. By default, all files are shown centered because we do not know if the files have a common range base. You can easily move the single point clouds as shown before with Shift-Click-Move. If we know or expect files with a common base, we can also remove the checkbox at Centered and click Align Automatic. The files will be aligned at their original positions. If you lose your orientation, it's best to center all datasets and reset your camera. Oftentimes, you may want to explore a detail in your data. I would like to now show you how we can do exactly this easily within the viewer. We always work with our view center. This is where your axes run. Let's assume we want to examine this green car, for example. So first, we switch to top view. Then we move by XY to the horizontal center of our target using a right-click move. Then we move a touch sideways to see our current height. Then we use a control right-click move to the center of our target in vertical position. Now we can easily zoom into the target and move around it. Sometimes you may want to separate a whole band of data. This is possible by activating the section function. You can define the section using the mouse or by entering the dimensions in the edit. Click Exclusive to limit the view to the planes. You can lock the planes and also hide them. You can use the center button to move the camera in front of the planes. If you change the colorized parameters or change the plane dimensions, you can recalculate the data within the section. These were some of the basic functions of laslook. If we check the main menu, however, there are some additional functions. First, we have project management. This feature makes it useful for saving different tasks of work in different projects. A project contains the working folder, the console content, and possibly also some notes about the project. This way, you can easily switch between tasks. The project history gives you fast access to recent projects. If you save a project, it is saved by default in the application directory. Optionally, you can save your project anywhere else. Independent of the project management, you also have a window manager. Set your environment however you like and save your favorite settings. The application can run in various different languages. The default language is detected during startup. The initial languages are English, Spanish, and German, and other languages may follow. The note function gives you the possibility to save notes to a project. Notes can be formatted as normal text or in markdown notation. All execution of LAStools commands are stored in a local SQLite database. This gives you an overview of recent actions and the option to find a previous argument setting. You can delete unwanted entries, and you can also enter notes relating to certain commands. An online filter function gives you the option to find files, commands, arguments, or notes swiftly and efficiently. The execution statistics also offer an option for automatic task planning and scheduling in future versions. These are the basic features of laslook, the new GUI tool of LAStools. Hopefully you'll be able to improve your productivity with LAStools using this program. Thanks for watching this video and working with LAStools. We look forward to hearing any feedback and suggestions you may have.